Dear students, welcome to the very short lecture 3.2 where we will discuss the frost action in soils. Look at these photos. The one on the right was taken in Norway. The pavement damage that you see was observed along 80 kilometers of this road and occurred after a very cold winter. The photos on the left were taken in Poland, and it is actually a picture that we use to see every spring. They all show the effect of freezing and thawing of soil. The pressure that is generated there may be sufficient to lift road surface, pavement, but also some lightly loaded foundations. This phenomenon is called frost heave. The water present in the soil voids turns into ice, forming continuous ice lenses, layers, veins, etc. The ice lens grows through capillary rise and thickens in the direction of the heat transfer until the water supply is finished or until the freezing conditions change. So as the ice lens grows, the overlying soil and the pavement will heave up, potentially resulting in a cracked, rough pavement. There are specific conditions necessary for the frost heave to occur. So first of all, we must have a frost-susceptible soil. Sometimes we call these soils heaving soils. Secondly, the groundwater table cannot be too deep, or the ground must be moistened by, for instance, a heavy rain. And the third condition is that the freezing must act long enough and intensively. Because when the temperature drops fast, so for instance quickly it becomes lower than -10 Celsius degrees, then the water has no time to flow to the freezing front before the material totally freezes. And as a result, no more water can move to the freezing front. In this case, the frost heave or the frost expansion will be quite low. But when the temperature drops slowly, the freezing takes a long time and the water has enough time to flow to the freezing front and grow the ice lenses. And in this case, the amount of the frost heave or the frost expansion is high. This picture is a good illustration of this phenomenon. So let's see what happens at the freezing front. Okay, so here we have the freezing front. First of all, the water in the large void space freezes into ice crystals along the plane of freezing temperature. Okay, so here we've got the ice crystals, okay, that are slowly forming along this plane. Then, as water freezes, a high degree of suction is created. It is because the vapor pressure of ice is much lower than that of water, and so it draws water upwards towards the frozen layer where it freezes and finally forms larger crystals. Okay. And of course the crystals then continue to grow, as you can see, fed mostly by the capillary water, forming ice lens. The vertical pressure exerted by ice lens can heave the surface, and this is because as water freezes, its volume increases by 9%. So the volume of the soil can increase also by 9% times the porosity per unit volume, of course. So usually it is around 2 to 6% depending on the void ratio. So for instance, in a soil that would have the void ratio equal to 0.5, with the frost penetration of 40 centimeters, the amount of surface heave would be 12 millimeters. And sometimes it is enough to crack the pavement. Here once again we see the effect of the frost heaving, as you can see here, right? Which is mainly, as it was said before, due to capillary suction. Now, if a rapid thaw takes place, then the soil near the surface, so like here, will contain an excess of water which will be unable to drain away through the still frozen soil below. The soil is therefore likely to be in some unstable state. Look at the picture on the right. We are talking about soils that contain some amount of fines. So as you know, the amount of water, so the water content of such a soil, is a very important geotechnical parameter because it is it tells you about the soil consistency. And you know that the more water the soil contains, the softer it becomes. And here you see two graphs. So this graph, okay, is the water content before freezing. And that graph here is the water content after freezing. So as you can see, the water from this region has been like sucked up by the capillary action to this zone. And so after thawing, this zone will contain more water than before. And it may be enough to change the consistency into too soft one. In this picture, you see the map of Poland with the frost penetration depths, because at least in Poland, the frost penetration can reach 80 centimeters, or in the most the coldest regions, 1.4 meters. And so this is the maximum frost penetration depth in the Poland. This map is used, for instance, when you design the path foundations, because then we want to know what is the frost penetration depth. And if, for instance, let's say that we are designing some foundation in Warsaw, right? And we know that in Warsaw, the frost penetration depth is then 1.2 meters, right? Or no, sorry, 1 meter. Okay, it is 1 meter. So it means that if in the first zone in the subsoil you have a soil that is frost susceptible, then you have to take the frost penetration depth into consideration. And the best would be if you designed the level of your foundation below this depth. Okay. Now, which soils are these frost susceptible soils, or frost or heaving soils? There are various definitions. For instance, according to Casagrande, these are the soils characterized by Cu greater than 15, so the coefficient of uniformity greater than 15, and containing more than 3% of the particles smaller than 0.02 millimeters, or with Cu greater than 5 and more than 10% particles smaller than 0.02 millimeter. I hope that you remember that this fraction 0.02 millimeters, it is somewhere in the CLT fraction. Okay. Okay, the second definition, according to some ASTM standards, so in the USA, they use this definition that the frost susceptible soils are the soils containing more than 3% of the particles smaller than, again, the same limit, so 0.02 millimeters. And according to the old Polish standard, this would be the soils containing more than 10% particles smaller than 0.02 millimeters, and all organic soils as well. And according to Professor Zenon Viłun, these are the cohesive soils. So cohesive means fine soils, warps, and as doubtful, very fine sands, silty sands, sands with humus, forming slightly cohesive lumps, all the soils with passive capillary rise greater than 1 meter. So if you have, for instance, silty sand, and this is a soil that maybe let's try to draw it here. So let's imagine that here we have the terrain surface, and we've got some layers in the soil. Let's say that the first soil is the silty sand. Okay, so the silty sand will be probably defined as a frost susceptible soil according to all these definitions. So if you want to put your foundation in this soil here, then you need to take into account the depth of the frost penetration, and then so put your foundation on a depth D that will be greater than the depth of the frost penetration. But if instead of this case, okay, you have a first layer made of clean gravel, okay, then gravel is not a frost susceptible soil. So it means that you do not have to put your foundation at the depth greater than the frost penetration. It can be shallower, okay? So it is important to know what is the frost susceptible soil and what is the depth of the penetration, of course. And then you can use this information when designing the depth of the foundation. Okay, thank you.